Hi, my name is Shakif Ashraf bin Yusuf. Okay, I will start the presentation by introduction. First, we go to the definition of biomass. Bio mean life in Greek, and mass mean an amount of something. Biomass is the term used in the scientific field to describe any fuel derived from the living organism. They can be categorized into two categories, that is primary, which is biomass that harvested directly from the primary source. Second one is secondary biomass, that is residues from the primary source. And then look at the picture on the right, that is the carbon cycle, which is the process of the carbon on the environment absorbed by the plants by photosynthesis, and then we use it as a biomass energy. After that, the byproduct is released into the environment, becoming the carbon in the environment back, and then the cycles returns. There are 6 typical biomass sources. There is forestry crops and agricultures, MSW or municipal solid waste, industries residues, animal residues, agriculture crops and residues, and then the last one is sewage. There are mainly 3 methods of harvesting energy from the biomass, that is by thermal, chemical and biological. In thermal conversion, we have pyrolysis, torrefaction and direct combustion, where in pyrolysis we heat the biomass product in complete absence of oxygen until it became a biochar. The same process in torrefaction, but a lower temperature is used in heating the biomass, and then direct combustion is directly burn the biomass product. Next, we have chemically conversion. We have 3 types of chemical process, that is pyrolysis, just like in thermal conversion, gasification, converting the biomass into the gas, and transesterification, that is converting the vegetable oils, animal fats into fatty acid that we can use as biodiesel. And lastly, we have biological conversion. In this type of conversion, we have anaerobic composting, that is collecting the organic waste such as animal and human dung into a tank in absence of oxygen, then let the composting bacteria to compose the biomass in absence of oxygen to let the bacteria respirate in anaerobic to produce biomethane. Second one is fermentation, which is we converting sugar such as sucrose, fructose and glucose into cellular energy by producing the ethanol. Those are the fuels that is produced by those process that can be used to heat up the boilers to make the steam and conventionally generate energy like the other power plant. In conclusion,
Assalamualaikum, my name is Nofatin Izzati binti Muhammad Fauzi. My metric number is 19109236. I will present my part is theory and mathematical models. Biomass power system use procedure like those used with fossil fuel to transform renewable biomass fuel into heat and electricity. Direct fire combustion system are used in most biomass power plants. They burn biomass directly to produce high procedure steam, which is used to power turbine engine. Burning, bacterial degradation and conversion to gas or liquid fuel are the 3 methods for releasing the energy trapped in biomass to produce biopower. First, for burning, direct combustion produces most of the electricity generated by biomass. To make high pressure steam, biomass is burned in a boiler. This steam causes a series of turbine blades to rotate by flowing over them. The turbine spin drives a generator which generates energy. Secondly, bacterial decomposition. Organic waste such as animal dung or human sewage is collected in digesters which are oxygen-free tanks. Anaerobic bacteria degrade the material here, producing methane and other byproducts to create a sustainable natural gas that may be subsequently be cleaned and utilized to generate energy. Lastly, conversion to a gas or liquid fuel. Biomass can be converted to a gaseous or liquid fuel through gasification and pyrolysis. Gasification is a method of producing synthesis gas, which is primarily composed of carbon monoxide and hydrogen. Pyrolysis is a process that is like gasification but operates under different conditions. This biofuel is then used to generate power in furnace, turbine, and engines. The biomass power system is similar as thermal power system in that operate using the principle of Rankine cycle. The biomass feedstock will be stored at the storage. From the storage, the biomass feedstock will be dried, green, and densified through stack. The postpine is sent to a steam turbine to generate electricity through the generator. Finally, the clean air is vented into the atmosphere or open air through a chimney. In this assignment, we consider a general model for biomass particle of arbitrary size in which chemical, physical, and thermal processes are taken into account. The model can be readily extended to 2 or 3 dimensions. The particle geometry can be spherical, cylindrical, or slab and is represented in a one-dimensional framework. For shrinkage model, the shrinkage factor is the factor that accounts for the change of volume due to particle mass loss which takes place when a particle undergoes a thermochemical conversion. The shrinkage factor theta is defined as the ratio between the current volume of particle to its initial volume. Value 0 represents constant density and 1 represents constant volume during thermochemical conversion. If charge oxidation is controlled by external diffusion, it can be assumed that during charge reaction the density remains constant. Shrinkage not only happens due to the loss of mass from the particle but also due to rearrangement of the chemical bond and structure of virgin biomass and charge. Second is pyrolysis model. Biomass pyrolysis is a multi-scale chemical and physical process. A fundamental modeling approach should be built up from the smallest relevant scale, taking into account the detailed physical and chemical processes. It was shown that for low moisture structure of the pulverized wood flame are not sensitive to the use different model. A systematic approach is employed to compute the yield of different gas species and composition of tar. Depending on the reactor condition, the amount and composition of char residue can be different. Typically, char consists of carbon and a smaller amount of hydrogen and oxygen. This means that for operating conditions similar to those of industrial furnace with high heating rate environment, the assumption of pure carbon for char is reasonable. Third is drying model. Drying is an important step during conversion of solid fuel either as a pre-treatment process or happening simultaneously or before pyrolysis. High initial moisture can reduce the particle heating rate by a factor of 3 to 5. Water inside the particle can be found in 3 forms: free water, bound water, and capillary water. Okay, that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Faiz Hakimi bin Rosman. Okay, firstly, biomass has been in use in people first began burning wood to cook food and keep warm. Wood is still the largest biomass energy resource today. Other sources include the food crops, glaciers, and woody plants, residue from the agriculture or the forestry, oil-rich alga, and the organic component of the municipal and industry waste. Even the fumes from landfill, which contain methanol, the main component in the natural gas, can be used as a biomass energy source. Biomass can be used for fuel power production and products that would otherwise be made from fossil fuel. Type of the bioenergy technology. Firstly, biofuels are the transportation fuel such as ethanol and biodiesel created by converting biomass into liquid fuel to meet transportation needs. Learn more about biofuel. Alright, the second type of the bioenergy is as biopower. Alright, biopower technology convert renewable biomass fuel into heat and electricity using one of the three processes: burning, bacterial decay, and lastly is a conversion to gas liquid fuel. Okay, lastly about the type of the bioenergy is bioproduct. Okay, right. In addition to electricity and a fuel, biomass can also be converted into chemical for making plastic and other products that are typically are made from the petroleum. Benefit of the biomass. Biomass can provide an array of the benefit. Okay, the second, greenhouse gas emission reduction. The use of the biomass energy has the potential to greatly reduce greenhouse gas emission. Burning biomass releases about the same amount of the carbon dioxide as a burning fossil fuel. However, fossil fuel release carbon dioxide captured by the photosynthesis millions of years ago. And essentially, news greenhouse gas. Biomass, on the other hand, releases carbon dioxide that is largely balanced by the carbon dioxide captured in its on the ground, depending how much energy was used to grow, harvest, and process the fuel. However, study has found that clearing forests to grow biomass result in a carbon penalty that takes decades to record. So it is the best if a biomass is grown on the previously cleared lands, such as under the anti-farmland. Alright. The thirdly of the benefit is foreign oil dependence reduction. The use of the biomass can reduce dependence on the foreign oil because biofuels are the only renewable liquid transportation fuel available. Okay, lastly, U.S. agriculture and the forest product industry support. Biomass energy support U.S. agriculture and the forest product industry. The main biomass feedstock for power are the paper millions releases, lumber million crab, and municipal waste. For biomass fuel, the most common feedstock used today are the corn grain for ethanol and soybean for biodiesel. Thank you for me. Assalamualaikum.
Biomass facilities can generate anywhere from 2 to 1,000 megawatts of electricity. At the end of 2014, Canada had 70 biomass power plants. Together, these plants can produce 2,043 megawatts of electricity. Industries such as pulp and paper plants use about 2/3 of this electricity. Atikon Generating Station is North America's largest 100% biomass power station. It is located in Northwest Ontario. This station used to generate power by burning coal. After modification in 2014, it now burns wood pellets. It can generate 205 megawatts of electricity by burning wood pellets. This is enough electricity to power about 70,000 homes. The three most common are natural gas, coal, and nuclear power. Some of the faster growing sources are renewable resources such as wind and solar. Most United States electricity is generated at centralized power plants. A much smaller but growing amount of electricity is produced through distributed generation. A variety of technologies that generate electricity at or near where it will be used, such as on-site solar panels, and combined heat and power. Approximately 86% of modern bioenergy is used for heating application, with 9% used for transport and 5% for electricity. Education students on the bioeconomy at NC State. The Sustainable Bioproducts and Bioenergy program serve to provide the knowledge and skills students need to advance the bioeconomy. The program is a collaborative effort between the Department of Forest Biomaterials and the Department of STEM Education and contains 4 courses, one of which Validity of Teachers called the Sustainable Bioeconomy. The course focuses on how sustainable biomass can be harvested and the type of products that can be made from it. In addition to social, economic, and environmental sustainability of these bioproducts. All course materials are available online for free and self-paced learning. Number 2 is harnessing woody biomass sustainably. The southern US is heavily forested, making it a crucial source of biomass in the region. There are over 40 million acres of pine plantation located across the region, a vast majority of which is owned by private landowners who harvest trees. These pine plantations make up a tiny portion of total forest land in the southeast, but are the main source of biomass used by the wood product and pulp and paper industries. The first one is Teluk Intan Biomass Power Generation. It is located in Perak and 12.5 megawatts and 44.62 million. The 12.5 megawatts biomass plant has started commercial operation since September 2014 and will process empty fruit bunch and wastage from palm oil production into fodder. That in turn will be used as fuel for the boiler. The boiler produces steam and generates electricity. With this technology, plantations and palm millers can put their waste to good use. It creates opportunities in generating electricity revenue while reducing carbon emission. The second one is Yala Biomass Power Generation Thailand. It's located in Yala and can produce 23 megawatts and costs 55.600 million. 25 years construction of the new electric thermal power plants began in August 2003 in Yala Prefecture of southern Thailand. The plant is designed to generate up to 2,000 kilowatts output power through the integration of rubber wood with. Many rubber tree plantations for the extraction of natural rubber are based in Yala Prefecture and the vicinity. There are also numerous sawmills to treat the logged rubber trees for sap extraction at the end of their life. Once they lose their productivity for sap extraction. Next is Kabangkala Biomass Power Generation in Philippines. It's located in Negros Oriental, can produce 46 megawatts and costs 66.200 million. Energy security is among the top concerns of the Philippines as a developing economy. Definitely, the response to such a challenge is to prudently manage the exciting supply of fuels such as coal and oil, upon which the country's energy mix has been mostly based. However, with growing worries on the environmental impact as well, the rising cost of this renewable source of energy, exploring other sources has become urgently necessary.
Assalamualaikum and good afternoon to my respected madam, Puan Lady. My name is Muhammad Akim Mulani. So today I'm going to present about my part of power system assignment task. In this presentation, it includes 2 parts, which is the advantages and disadvantages biomass power system. First and foremost, due to the abundance of plant on Earth, biomass has the potential to be a significant source of renewable energy that can be utilized as long-term replacement for fossil fuel. Biomass is regarded as a renewable energy source since it can quickly regenerate and because it emits energy come from the sun. The carbon dioxide that trees have taken in from the atmosphere release back into the atmosphere when they die. Furthermore, our over-dependence on fossil fuel is reduced by biomass. Fossil fuels are not only limited in supply but also have detrimental consequences on the environment due to the high volume of carbon dioxide they emit into the atmosphere and pollutant that they create during production, transportation, extraction. What role does biomass play in reducing our reliance of fossil fuel? Numerous fuels such as bioenergy, also known as energy from biomass, is sustainable alternative to fossil fuel that may be produced from renewable sources like plants and waste that can be continuously supplied. Next, the production of biomass provide manufacturer with a new stream of revenue by converting their garbage into the biomass energy, which is more profitable application for it. Waste producer can add value to their waste. Biomass technology is far more affordable than fossil fuel extraction, which is involved a large capital investment such as oil drilling, gas pipeline, and fuel collecting. Producer and manufacturer might make more money from a smaller production by generating new jobs, boosting economic growth, and fostering a greener environment by reducing emission and air pollution. Biomass energy provides the local community with significant economic benefits. For disadvantages part, other than that, biomass compared to fossil fuel, biomass energy is less efficient. The main disadvantage of biomass energy are that it is expensive, requires a lot of space, it still releases greenhouse gases, it can have a negative impact on the surrounding environment, and it is inefficient in terms of how much energy it takes to create electricity. Some biofuels such as ethanol are less efficient than gasoline. In order to boost in effectiveness, it actually has to be strengthened by fossil fuel. In addition, biomass is not completely clean. Even though biomass is carbon neutral, combining human and animal waste increase the amount of methane gases, which is also bad for the environment. Furthermore, pollution from burning woods, plants, and other natural resources can be contrasted with pollution from burning coal and other type of fuel. Burning organic material produces heat, which is creates steam, which power of turbine to produce electricity. This process is known as biomass or organic matter. Lastly, biomass may lead to deforestation, since one of the most popular biomass energy source is wood. Huge amount of wood and other waste must be burned in order to produce the necessary amount of energy. That is a danger of future deforestation even if there is currently enough wood debris. Does biomass lead to clearing of forests? The biomass energy sector transforms trees into wood pellets, which are the burned at utility scale to generate electricity. Companies that employ biomass wrongly promote this method as clean energy. Yet burning trees for energy can produce more carbon pollution than burning coal and has a long-term negative impact on forests and wildlife. That's all from me. Thank you.
We have the data here which show that increment in uses of renewable energy, including the bioenergy that we talk about, from 79 terawatt hours in 1985 to 763 terawatts in 2021. If we can see the graph here, it shows the accumulative of carbon dioxide emission by the years. From the early of 18th century, a very drastically increasement of carbon dioxide emission. This CO2 can lead us to global warming. Global warming can give us four main effects on us. That is increasing world temperature, rising of sea levels and shrinking mountain glaciers and accelerating the ice melt. Hopefully, by using the bioenergy and alternative energy such as biomass, we can decrease the emission of carbon dioxide.